from what we have learned previously, all what we need to do to put something in orbit around the Earth is to give it an initial horizontal velocity that's large enough such that the amount by which the projectile falls every second corresponds to the curvature of the orbit. So for every orbit, we can have a particular initial velocity that we can give our projectile to put it in orbit. So for example, in this particular orbit, we are going to need a particular velocity. This one here, we need a slightly different velocity. If you notice here in this particular graphic, we have a space shuttle, we have the moon, we have a tree that's as large as the orbit of the space shuttle. But anyway, for every orbit, depending on how far are we from the center of the Earth, we are going to have a particular initial velocity that we can give our projectile to put it in a circular orbit around the Earth. Of course, if instead of the Earth we have another planet or a star, the values for the velocity are going to be different, but the principle still applies. It is beyond the scope of this course to figure out what that velocity is, but it's not really something very tricky. It can be very easily calculated. Now, the key thing that we would like to get out of this is the fact that when we put something in orbit, we just give it an initial velocity. We don't need to keep on propelling it into that orbit. We give it an initial horizontal velocity. We kind of toss it horizontally. It's very much like when we toss something horizontally like this. In other words, something in orbit is something in free fall. Okay, what does that mean? What are the implications of that? For example, in an amusement park, one of the rides is what we call a free fall. You'll sit in that particular ride and they drop it and you experience for that short amount of time what we call a free fall. So what do they do there to get you to experience the free fall? Essentially, they drop the box. They just let go of the box. And you fall along with it. That way you experience the free fall. When you are in a space shuttle, for example, that's the same thing. Instead of dropping it with an initial velocity as equal to 0, it is being dropped with a horizontal velocity. The horizontal velocity is not going to affect the fall. In other words, someone in the space shuttle is in free fall around the Earth. That's why when you see pictures, videos of people on the space station or the space shuttle, you'll see them experiencing what people usually call weightlessness, but it's not really weightlessness. They are in free fall. They are in free fall as well as everything in the space shuttle, and that's why it's going to look like they are weightless.